In recent times, a lot of celebrities have voiced their support for renewable energy, the removal of greenhouse gases, and the idea of going green. Leonardo DiCaprio is a big example, and since he basically owes his career to them, it makes sense that he wants to save the ice caps from melting. Seriously, everyone else has gone green, except Vin Diesel. And everyone else includes Microsoft founder Bill Gates and a company called Carbon Engineering. But perhaps Bill Gates and this company may be the most influential actors in fighting climate change as we move into the future. So what technology is Carbon Engineering going to introduce that will change the world? Well, let's find out in this video. But first, welcome back to our channel. If you haven't already, make sure you hit the subscribe button and ring that bell so you're notified every time we upload a new video. Carbon Engineering was founded in Calgary, Canada by a Harvard professor named David Keith. The goal of the company is to develop a carbon removal technology that removes carbon dioxide from the air at a megaton scale, and to commercialize the entire venture. Carbon Engineering utilizes two technologies to make this goal a dream: direct air capture, or DAC, and air-to-fuels. As you can already imagine, air-to-fuels is a technology that will generate low-carbon renewable fuels from the air. That's an oversimplification, but you get the point. And this air-to-fuel technology is impossible without the direct air capture technology since, air. Direct air capture involves the capture of carbon dioxide from the air. This process is carried out in 4 steps, beginning with a fan that sucks air into a compartment where it is mixed with a liquid to trap at least 80% of the CO2 at the bottom of the compartment. The liquid is then precipitated to give carbon-rich calcium carbonate pellets. These pellets are in turn heated to give off the standalone carbon dioxide. The final step involves choosing what to do with the CO2, and there are 2 choices. Of these 2 choices, one will have a carbon negative effect without any financial gains. What carbon negative means is that the amount of CO2 in the atmosphere has been reduced. The second option has a carbon zero effect with financial value, and carbon zero effect means that no carbon dioxide has been added to the atmosphere, but neither has any been removed. The first choice is called geological sequestration, and it involves the use of underground reservoirs to store the carbon dioxide indefinitely. Therefore, the atmosphere has less CO2 in it than when the process started, hence a carbon negative effect. The second option makes use of the air-to-fuels solution to produce renewable fuels. This is done by using clean energy like solar photovoltaic technology to electrolyze water to hydrogen and oxygen, and at the same time provide electrical power to the fuel synthesis process. Fuel synthesis takes place between the hydrogen from the electrolysis of water and carbon dioxide from the direct air capture. This produces hydrocarbons which can be used as drop-in compatible fuels for engines directly or after being refined. These ultra-low carbon fuels will be burned up to release the CO2 gotten from the atmosphere in the first place, only to be sucked back in by the direct air capture process. This process repeats itself with renewable electricity and renewable resources. Now, after starting out in 2009, Carbon Engineering invested their time in research and development and prototyping. Finally, in 2015, the company moved to Squamish, British Columbia to set up its pilot plant. In this plant, in 2015, Carbon Engineering carried out their first direct air capture, and in 2017, they made their first air-to-fuel synthetic fuel. Also, the company is one of a kind, seeing as they drove down prices required for direct air capture all the way from $600 per ton by other DAC companies to as low as $232 per ton, or even lower at $92 per ton. With funding from Bill Gates and Oxy Low Carbon Ventures, they are planning to build the world's largest direct air capture facility in the Permian Basin, Texas. This plant is said to be able to remove 1 million tons of CO2 annually, thereby doing the CO2 processing work of 14 million trees. At that rate, Carbon Engineering would need 40,000 plants worldwide to get the levels we need for global warming to be below the safe 1.5 degrees. For a perspective of the costs, let's take CO2 emissions from 2017 as an example. In 2017, 32.5 gigatons of CO2 was released into the atmosphere. If Carbon Engineering was to get that amount of pollution out of the sky at their rate of $92 to $232 per ton, the calculations suggest that they'd end up spending $3 to $7.5 trillion on 2017 alone. And although Bill Gates is filthy rich, he definitely cannot pull that off. However, both constraints do not signal the end of the project, because although 40,000 plants sounds like a lot, and it surely is, there are several types of plants with more plants worldwide, with an example being power plants. Meanwhile, if the cost of DACs can remain as low as $150 across all operations, air-to-fuel could then return profits that will cover the cost for further operations. Now, some of you may be wondering, why can't they just install these devices on those chimney-like things of industries? And the answer is, well, they already do. In fact, carbon capture has existed in some form for some decades. This is because, during the refinery, these companies used a more primitive method to extract carbon dioxide. This carbon dioxide was then used in the extraction process of crude oil. However, the aim of direct air capture and geological sequestration is to create a carbon negative effect. Attaching the DAC technology to factory chimneys will not stop carbon being created and added to the system from burning these fossil fuels. It just maintains it and adds it to the carbon zero example we saw above. However, DAC and sequestrations reduce not just the CO2 being put into the air today, but also the excess amount that remains in the atmosphere from the past, and that is absolutely necessary to create a negative. DAC seems like an absolutely perfect technology that everyone should look forward to. However, like every other thing in this world, but ice cream, it has its detractors, and these global warming discussions sometimes get heated. And to be honest, critics do raise some good points. For instance, there have been concerns about geological sequestration. One is that it's not exactly clear what the effect of the carbon dioxide will be on the soil and plant life in the area. Also, there are concerns about what the effects may be if one of these reservoirs lets its CO2 free through some accidental discharge. Also, there have been concerns that a technology that uses the help of fossil fuel companies like Oxy Low Carbon Ventures and Chevron cannot possibly be working with a genuine goal of healing the earth. Also, a different school of thought proposes that planting trees to act as the natural sink they are is the better way to go. However, this clearly doesn't have to be an either-or situation. There's so much work to be done that all hands need to be on deck with this one. We need both the plants and the plants to cover as much ground or air as we can. As for the fossil fuel company critics, there is every reason not to like those guys. However, as it stands, these are our major sources of energy. If we were to shut them down, the world would definitely descend into chaos faster than the imminent disaster of global warming. This is why, despite his efforts to use more expensive and eco-friendly things like aviation biofuel, Bill Gates still refers to himself as the imperfect messenger, since other aspects of his life still leave a carbon footprint. We cannot currently detach them from our lives, but they can take us to the next stage, and being at the forefront of a new energy source may be good enough motivation for them to want to put their weight behind DAC and air-to-fuel. So if there's a chance that direct air capture can save the planet, then we must try our hands at it. Shortcomings with the system should not be seen as a reason to shut down the project. Rather, it should be something to improve on and make it the best possible version that it can be. But what do you think? Do you agree with the critics that direct air capture and geological sequestration is a waste of time? Or do you think it's worth trying out? Let us know in the comments below. And if you enjoyed this video, make sure to give it a like, and check out more awesome ones on the Simply Tech channel. Thanks for watching, and we'll see you next time.